Hello again, everybody. Net torque. Last video we learned what torque was, kind of the cousin of force, and of course we spent a lot of time looking at the net forces on objects. This video, pretty quick, we're just looking at what happens if there are multiple torques. What we do was very similar from what we did with forces. We analyzed the net torque, the total amount, okay? Now let's just remember a couple of important things from the last video. Okay? A torque is the cousin of force. It's what causes things to rotate or to change their rotation. All right? It is based on force, but it's also based on R. R being the distance from the hinge, or this is sometimes called the axis of rotation or the pivot point, sometimes the fulcrum. It's kind of the location where the object is orienting around. Okay, so hinge is usually a pretty common word, but R is the distance from the hinge to where that force is acting. Normally, it's right along the direction of that object. If it's a door or a rod, right along that rod. So this here is R. Okay, it does also depend on the angle. Okay, the maximum torque is going to come from when that force is perpendicular. Usually that's going to be measured perpendicular, or you're going to find the perpendicular component from that radius. So right here, that's already perpendicular to this force, so it would just be R times that force. You could break down the radius. That's a little weird, but if you could do that, or if you want to do that, you could, and that'd be acceptable. All right, so there's our basic reminder. Remember, the units for torque are Newton times meters, Newton meters, okay? Well, I have that same diagram, or at least a very similar one from the last video, where I have a pulley. And a pulley can have one force, two forces, three forces. If there are multiple forces, and therefore, since they're going to be acting distances away, right? So here's my R for the pulley. Okay, so from that radius to where the force is acting. Okay, there's another R. All right, if there's multiple forces, that means there are multiple torques, and therefore, to find really the overall motion of this object, you want to look at the net, the total amount of torque. Okay, so I have these two different forces. I'm actually going to have one of them I'm going to label as blue, just because I'll want to use a couple different colors. So this one I'll have as my blue force, and then this one right here I'm going to have as, I'll just keep it as red. That'll be my red force. So I have a blue force of 20 newtons and a red force here of 30 newtons. Okay, just so I can color coordinate a little bit. Now, how would I set this up if I wanted to figure out the motion of this pulley? Okay, now it probably isn't too surprising, and I'm holding a pulley right in front of my head. If I apply a force on this side of the pulley, you could imagine it's going to rotate this way. Okay, it's obviously going to rotate in this kind of direction here. Okay, counterclockwise as you're seeing it in my video. If I applied a downward force on this end, well, it doesn't take too much imagination to think that it's going to be rotating the other way, clockwise. These are competing torques, just like we saw forces in opposite directions are competing, so to speak. So we might be adding torques if they're in the same direction or subtracting if they're in the opposite. First thing, we're not talking about left or right anymore. We're talking about clockwise motion or counterclockwise motion. Okay, that's how we're going to be looking at the motion of objects now. And we need a positive and a negative. By convention, to be honest, it's a little strange. It's not super intuitive. By convention, counterclockwise is taken as the positive direction. I actually don't know why. Maybe you could Google that and put it in the comments if you like. But the counterclockwise direction is known as the positive direction most of the time. Okay? And like we did for forces, I recommend you label very clearly what directions you're saying are positive and negative. Notice I have this kind of arrow that's clearly showing that counterclockwise, that's positive. So what do I do to set up the sum of the torques? Well, it's just like we did before. I'm going to write out the sum of, not forces, I'm going to write the sum of the torques. Okay, there's two torques acting on my pulley here. There's this red torque and there's this blue torque. So I'm just going to put the one in blue for right now. I know maybe if you're copying these notes down, maybe you put like blue or the torque with the little 20. You don't always have to write that down, but just so we're on the same page. And I also have this red torque, so the torque right here, and that's the 30. Okay, you could write it down like that. You don't have to. Now, we're going to get into what these add up to later on. For this video, we're just adding, okay? We're just seeing what the net torque is. Well, all right, I have blue, I have red. They're in opposite directions. Should I be adding or subtracting this red torque? Well, if I'm saying that counterclockwise is positive, this blue force, that's going to cause it to rotate counterclockwise. Maybe I should have done that in blue, okay? But the red force is going to make it go clockwise. So the clockwise, torque, that should be negative by my convention. Okay, So that's going to be R times that force. Now, they're both perpendicular from my last video. They're already perpendicular. I don't have to worry about any angles. Minus R times the red force. And again, maybe if I wanted to be really careful, this is the 20 Newton force. This one right here is the 30 Newton force. Okay, what's the radius? The radius is 0.02 meters. It's 2 centimeters, or 0.02 meters, times 20 minus, same radius, 0.02 times 30. Well, okay, what's 0.02 multiplied by 20? It's 0.4. If I'm making a math mistake, again, let me know in the comments. Sorry, I have to move over a little bit. What's 0.02 times 30? I got 0.6. My ultimate final answer, what's 0.4 minus 0.6? I have negative 0.2 Newton meters. That is the total net torque. What does this negative sign mean? It means that the total torque is in this direction, the clockwise direction, because negative is my clockwise direction. Does that make sense? Yeah. Notice, if I have two forces, one larger than the other, and they're the same distance away, it probably makes sense that the larger force is going to kind of win that battle of getting my pulley to rotate. So that's it. Looking at the total torque is very similar to looking at the net force. Write out the sum of the torques. Just keep track of which ones are positive and negative. That's all. I'm out of here. Thanks for watching.